Automatic sprinkler systems are unsurpassed fire protection devices. The basic components of sprinkler systems are sprinklers, piping, valves, and fire department connections. Sprinklers sense the fire, react to that sense, and then deliver the water to the fire area. The sprinkler system piping is classified by function. Valves are available in a variety of types to meet specific system needs. Sprinkler system designs may be wet pipe, dry pipe, deluge, or pre-action, and are select depending on the classification of the commodities protected. Qualified fire department personnel may inspect sprinkler systems, but should never personally or physically operate, adjust, manipulate, alter, or handle any sprinkler devices or equipment during situations other than emergencies or planned training sessions. Specific inspection methods and criteria depend on the type of system installed. Fire department personnel should verify that sprinkler systems are restored to service after a fire incident and should take appropriate steps to prevent sprinkler system impairment. Residential sprinkler systems differ from standard sprinkler systems in a number of significant details, but remain a highly effective device for reducing fire damage and preventing injuries and loss of life. History. Sprinkler systems were first installed in large industrial mills along the northeastern United States over 100 years ago. Their introduction can be attributed to Henry S. Parmalee, who was looking for a way to protect his piano factory from the ravages of fire. He invented the first fire sprinkler system in 1874. Today, sprinklers are unsurpassed as fire protection devices. They have extremely high effectiveness and reliability ratings when installed properly, and most failures are due to improper installation or a lack of maintenance.
This is the FM Global Test Center in West Gloucester, Rhode Island. The test you are about to see demonstrates fire development in two similar arrays of palletized storage. A split screen allows us to compare the progress in each array. The array on the right is protected by automatic sprinklers. The array on the left has no sprinkler protection. The test commodity is cardboard cartons with metal liners simulating a non-combustible product, such as a washing machine, stored in a cardboard carton that might be found in a typical distribution warehouse. Note that the fires initially grow almost identically. The intensity and speed at which the vertical spread accelerates allows flames to reach the top of storage just 25 seconds after ignition. Within 58 seconds of ignition, the first sprinkler head above the storage at the right operates. Sprinklers operating above the storage are cooling the burning surfaces and pre-wetting carton faces so additional stock will not be consumed. They are also cooling the gases at roof level, which reduces the temperature that exposed structural members might experience. Under actual emergency conditions, the water flow alarm would now be sounding, alerting a security guard, worker, or possibly a central station or public fire department. Although not clearly visible on the right, sprinkler water has begun to control the fire, reducing the chance of fire spread. The unsprinklered fire, on the other hand, is growing in intensity and involving new burning surfaces, releasing heat at a rate that would easily ignite nearby combustibles. The unsprinklered fire is well on its way to total consumption. Fire would now be jumping aisles and spreading to nearby stock. The controlled fire on the right allows for decisive action. There is no danger of roof collapse and no concern the situation may be getting out of control. Fire is at the point where it can be extinguished easily with small hose streams. Instead of a major fire resulting in total loss of the building and its contents, sprinklers have controlled the fire quickly, minimizing the extent of damage not only from fire and smoke, but from excessive water damage caused by hose streams. The cartons on the left have collapsed, just as they would in a typical storage fire, spreading burning debris over a large area of the building, involving more nearby products. The majority of the cardboard boxes have been consumed. A fire like this in an industrial plant could mean disaster to the building. Hose streams can now be used to complete extinguishment. Large flows of water will be needed to complete final extinguishment and mop-up operations.
Sprinklers are installed for a variety of reasons. Typically, the mandates are based on a previous fire history that led to code changes. However, Some smart business owners elect to install sprinklers even when not mandated as part of their risk management plan. The standards governing the installation of sprinklers vary based on the type of occupancy. Generally, though, as you perform occupancy inspections, you should have a basic understanding of NFPA 13 and NFPA 13R. Having an understanding of these two standards will help you ensure that the systems are in service providing the protection they were designed for. According to the NFPA, there has never been a multiple loss of life, 3 or more victims, in a building with a sprinkler system except in the event of intimate exposure to the fire or explosion. While systems will vary widely from occupancy to occupancy, knowledge of the basic components is critical. As a company member conducting inspections, you should be able to recognize the components and whether or not they are in serviceable condition. The sprinkler head performs several functions and is critical to the effectiveness of the system since it senses heat, reacts, and delivers the water. The 3 components firefighters should be aware of are the heat-sensitive device, the deflector, and the orifice. Because the sprinkler is heat-sensitive, there is a delay between ignition and the device responding. This is the sprinkler response time delay.
The automatic sprinkler system is the most cost-effective form of fire protection. Sprinklers are effective because they control and limit the spread of fire. That sounds simple enough, but how do sprinklers actually work? The sprinkler is designed to disperse water into evenly distributed droplets in an umbrella pattern over a predetermined area. This discharging water cools the fire area as well as pre-wetting surrounding combustibles. Thermoresponsive assemblies are designed to activate the head at a predetermined temperature to permit the flow of water, enabling the sprinklers to operate. The first and most common thermoresponsive assembly is the fusible link. It consists of 3 pieces of metal soldered together by a heat-sensitive metal alloy. When the heat reaches the head's operating temperature, the solder melts, the links separate, releasing lever arms and the cap, and the water begins to flow. Another thermoresponsive assembly is the glass bulb. When the head reaches its operating temperature, the chemical liquid expands and ruptures the glass bulb, and the sprinkler discharges water. Regardless of the thermoresponsive assembly used on a sprinkler head, they have one critical function: to actuate the head and the flow of water at the proper time. An essential factor in proper sprinkler operation is an adequate flow of water. At the same time, we do not want too many sprinklers to operate, as too much water discharging can overtax our supply or cause needless water damage. The sprinkler's density is described as the amount of water released over a specific floor area. It is usually expressed as gallons per minute per square foot. Density is a function of pressure and orifice size. Depending on the occupancy, more or less cooling water may be needed. In a furniture manufacturing plant, assembling of wood chairs is classified as an ordinary hazard because wood releases only 8,000 BTUs per pound per minute when it burns. A density of 0.2 of a gallon per minute per square foot provides adequate protection here. Polyurethane releases 13,000 BTUs per pound per minute when it burns. Because of the increased hazard of this material, we must increase the density to 0.3 of a gallon per minute per square foot. The first method we'll consider for increasing the density is to change the temperature rating using a higher rated temperature head. This allows more concentration of water on the immediate fire area. It has been proven that if the temperature rating of the sprinkler is too low, heads outside of the fire area will fuse in a high heat release fire.